Hello, I'm Mark Schildhausen. Because things on the internet seem to lose their date references pretty easy. Today is Monday, February 5th, 2024. In the last couple of days, I had the opportunity to do some maintenance work on my wife's Hogwarts Express O scale Engage Lionel layout, which you'll see in the video. And one of the issues was what's identified as turnout number 4 was intermittent. Now, it's been intermittent for a long time. When we bought the initial set and then started buying the pieces for this layout and started building the cabinet, it took quite a while, because at that time I was full-time employed and had a couple part-time jobs. I was pretty busy. But turnout number 4 was always a problem. Sometimes the light wouldn't come on either in the controller or at the turnout. Sometimes it wouldn't respond. It was always a problem. And by the time that I had the time to take care of it, we'd owned that turnout for probably 2 or more years. And I didn't even remember where I bought it, because I bought it from different places. So I asked Lionel a couple questions back then, got some nonsensical answers that don't make any sense, which is definition of a nonsensical answer, and just searched social media and got nothing relevant to it. So had the layout up the other day, started thinking about it, started looking at it, trying to figure out exactly what was wrong with it, and decided that I was going to take the controller apart, which is what this video is about, and investigate it. And it turns out that the screw for the common was jammed all the way up, no compression on the common, so the common was an intermittent connection, and that was the problem. Well, because it was jammed and I couldn't even get it started down, I took the controller apart and soldered hard leads to the bottom. So this video, and one of the things I wanted to do, and the combination of the two things, intermittent controller, and I wanted my switch handles to correspond to how the turnout was going. So when I pushed the handles forward, the train went away from me on the turnout. When I pulled it to me at the control point, the train came towards me on the turnout. And I wanted to do that, and I asked Lionel how to do that, and I got another nonsensical answer. The answer is really simple. There's 4 wires on the controller, and there's 4 wires that lead to the turnout itself. Yellow on, I'm going to call it connection number 4, and then on connection number 2 is a black, which is common. I have no idea what the yellow does. Number 2 is black, it's common, and then you have red and green. And if you swap the red and green on terminal 1 and 3, the position of the handle in relation to the turnout changes. So now I have all my controllers set up. I push the handles forward, the train goes away from me in the turnout. I pull the handles towards me, and the train comes towards me in the turnout. And that's what I wanted, and turnout number 4 works. This is a video showing you what I had to do, and I already had the controller together, so I can't show you that, but it's pretty simple, and I address it in the video. If you've got the similar problems, you can take the 3 screws on the IC board, the integrated circuit board, out, flip the thing over, and solder the leads to the backside. Make sure you're using a pencil, not a heavy-duty soldering gun. So, turnout number 4, now up and operating steadily, correctly. All the switches, controllers are relational the way I want them, and the board is the entire layout, which I'll show you, is working fantastically. So I'm pretty happy with it. Let's get on with the video. This is the pamphlet from Lionel for the FasTrack 036 remote switches, and I'm referencing it as we go through this. So I'm giving them full credit for it. I have some issues with it, or I wouldn't be making this video. One of the issues we had was I had bought the switches probably a year before I actually took them out of the box. I was doing other things and had other priorities. When I took them out of the box, I was setting them up on the floor and running, and they weren't running all that well. They weren't operating all that well. Part of the issue was you have to have the train in neutral with adequate track power, or you have to have the train moving at an adequate speed to provide adequate track power, and before switching before throwing a switch. However, the switch that would be numbered 4 in the installation was always problematic. The lights at the switch wouldn't come on to indicate whether it was a straight through turnout or a take the diversion turnout or whatever. And sometimes it wouldn't respond, sometimes it would. It was problematic. In taking it apart later on, I would discover that in this photo, you see the 4 wires attaching it from the top to the bottom. They're yellow, green, black, and red, and the black is common, and the screw on the problematic one was all the way up. It was jammed all the way up. We couldn't turn it, and the contact of the common wire was intermittent. What I did to resolve that was I took the board off, and I'm going to show you how to do that, and I soldered it to the bottom, and that was one of the fun things we had. I had asked on social media, and I emailed Lionel and asked, how do I change the switch handles so that when I throw them forward or pull them back, they don't do the default. I want them to be switched around. I want to mount them relational to my turnouts. And I got some confusing answers back, and one of them was I reverse the middle 2 leads, switch number 3 to number 2, number 2 to number 3, and switch number 4 to number 1, and switch number 1 to number 4. That's not the way to do it. Yellow, I don't know what yellow does, but yellow does it. It does whatever it does. It doesn't matter. The 2 that you want to switch are the red and the green, which is relational. You don't want to even remove the black, which is the common or the ground, and you don't have to do anything with the yellow. Just flip the red and the green. It is easiest to do this at the switch, at the turnout, underneath the turnout, than it is at the control handle. But as you saw in the other photo, you can do it at the control handle if you want. I watched several of the Lionel quote-unquote official videos on YouTube, and I picked up this one because I was looking for a transformer. I'm using this page in their provided manual that says voltage is recommend is best 5 to 18 volts AC. So I got an 18 volt AC transformer from the Home Depot, and I was about to hook it up as an independent source. I wanted to stay away from the CW80 transformer power supply. And in watching one of the videos, it says don't use over 12 volts because the incandescent lights will get hot enough to melt the hood. So my question is, if greater than 12 volts is going to damage the hood over the light, why does the manual show 18 is acceptable? So I'm now using the alternate, the accessory power off the CW80. Because of my professional maintenance and engineering background, when I hooked up the switches, the turnouts for the alternate power source, took the jumper out as shown on this page, I happened to have 2 colors available to me. They were green and blue, and because green is quote-unquote ground, I put green in all of the auxiliary ground connections. The left-hand connection is you're looking at that upper left block, or at the lower left block, the lower right block, doesn't matter. And I used the blue in the aux in. Now this is an AC system, so it turns out that that ground, that auxiliary ground, has to go to the black terminal on the CW80. If you put it on the red terminal on the CW80, it's going to go into overload. The green light on the CW80 is going to flash. That drove me absolutely nuts. I was trying to figure out what was going wrong. Then I went back to ground, goes to ground, treat it like DC, and that was one of the lessons learned. Run this with two colors, whatever they are, but annotate that the one color, say green, has to go to the ground, and the green is going to the black. And then say the blue is going to the aux in, and that's going to the red terminal on the CW80. Page 9 explains, if you get that far, gives you the clue as to what's happening here. Very top, the green wire goes to through, black wire goes to green, goes to ground, red wire goes to out, and yellow goes to RSC lights. I have no idea what RSC stands for. I found it nowhere in the reference. That's just poor tech writing to have an abbreviation. I don't know what RSC stands for. I'm not familiar with it. Anyways, the green is where it's at. And recommendation: if you can stay away from opening up the controller, controlling switch, do so. Stay with making your changes on the turnouts themselves. As I said, it's recommended that you make the changes at the turnout itself, underneath the turnout itself. In another video, it stated that, and it's not an official Lionel video, it's someone else's video, that you can hook multiple turnouts up to a single controller just by going to these terminals and then paralleling them off. So if you put two opposing switches, turnouts, you can set them up to one controller. Say for a crossover, you can flip one controller, and the two opposing switches, turnouts, both go to out rather than straight through. Kind of cool. My wiring was to the point, and my recommendation is you give yourself at least 6 to 8 inches of pull through if you are mounting wires underneath the board. I gave myself about 4, and it turns out to be inadequate. So to shorten one of my power leads, I had to go into the controller. So I'm going to show you how I shortened the wires, and because I had to take the controller almost completely apart, flip it over, and solder the leads to the bottom, I'm going to address, and I wish I could show you, but I'm not going to, how to do that. So this is my controller number 2. I'm using double-sided foam tape to mount my switches, my controllers, and that's the residue. These 4 screws come out. They are a very small Phillips. I have an eyeglass screwdriver set, and this was the medium size out of there. They're very small. And I recommend you be working over something that's going to catch these screws. You're dealing with a lot of small parts, so numerous small parts here. Cookie sheet works really fine. I had a piece of cardboard that had a distinct slope to it, where if something fell on the cardboard, it was going to roll off into a specific area and be collected. The cover is off, and the next step is, if you're going to have to take the board out and solder the leads to the bottom of the board, like I had to do on switch on turnout controller number 4, you're going to have to take this half moon clip out, use a very small straight blade screwdriver, and ease it out. If this shoots, it's going to be fun to find. It is magnetic, so that may help you out. Just ease it out, and you make sure you don't drop it. And this stuff is indexed as you take it apart, and we'll show you as you go. The half moon clip is sitting off on the side in a very special area, so I don't lose it. And these are the pieces that come out with the handle. Now that bottom left piece, and there's a bit of solder in here, you can ignore that. That was from the Turnout controller number 4 repair. The bottom left corner piece, that kind of X or star piece, cross piece, has not got a round hole, and the short extension on the control handle itself is also not round. They are indexed for a very specific reason. They go together, and this gives you the rocking motion that you need, and you have a momentary contact switch at each end of the throw, and that spring centers it back up. 2 photos of the base of the controller, and one side is indexed, has this limiting feature on it, which I put my finger in it so that it's more distinctive, and you have to make sure that the control lever goes in with the matching component on that side, otherwise it won't fit in right. One of the things I learned was when you put the spring on the short extension on the control handle, and then you put that that X thing on top of it, to get it into the controller base, easiest is to keep it pointed spring side high, take the controller base and above it and lower the controller base down, and then have someone else insert that pin. My wife was around, she helps me with this. She inserted the pin and it went together without a problem. One of my recommendations, and for some reason it didn't turn out right, I indexed what the colors were in order that were the default colors, and I also put them in the manual for later use. Highly recommend that if you're going to do this on something like cardboard, which is what I did, you draw the outline of the controller base, and you letter where you fill in where the colors are, so you know exactly where those colors go, even though it's not that hard, whatever. And the controller is now pretty much back together. All I've got to do is put the cover back on it and put new double-sided foam tape on it. My control panel is actually a drawer, and everything is stuck down and set up. When I want to operate it, take the cord, open the drawer, take the cord out, plug it in. Everything else is hardwired. I don't have to do any additional wiring. And when I'm done with it, unplug it, put the cord in the drawer, close the drawer, and it's off and running. And I'm pretty happy with it. Turns out to be really nice, and I'll show you a picture of I'll show you an image of what my layout looks like. I enjoy this. Here's a photo of my layout taken at a different time, and 6 remote control switches, a basic oval, a siding track, or a station track, whatever you want to cross, and imposed on a figure 8, and it works really well. I have a lot of fun with it. I prefer operating railroads, operating trains, rather than building scenery. Scenery is my wife and my granddaughter's project, and my Atlas Tyco Jeep GP7 is sitting there because of when this photo was taken. I would assume that the S scale FasTrack, S gauge FasTrack switches are going to work the same way. That's my next project, is my S scale board, working on the same concept as this, and trying to get the switches so that they're relational, so when I throw the switch handle away from me as the controller, the train would go away from me, and when I pull the switch handle to me at the controller, the train would come towards me, or not leave me, so to speak, as it goes. And my control station on this is on the upper side of this photo. It's where my control drawer is. It's near the 2 parallel tracks. Hope this helped you. The major problem I had, the major problems I had was one of the switches came out of the factory with a poor ground. and I corrected that the only way I could. I disassembled it, soldered the leads to the bottom. I do electronics work every once in a while, so not a big deal. The second one was I did not give myself enough slack underneath the board when I wired this up, at least 6 inches on all your wires so you can lift the track up. These are all hard mounted tracks, and I found a substance which I'll try to find. Well, I looked and I can't find it. Found a jar. It was an ad on social media. About 2 ounces of a grease type stuff. Wipe it on your rails and they don't oxidize, they keep contact. And I will tell you, this board stores about 6 feet from my stove on my den, which has a breakfast nook to it, so it gets exposed to everything. And that stuff just worked out fantastic. If I ever find it wherever it went to, I would assume it's in one of my supply boxes. I'll post it somewhere. I hope this helps you. You can flip the reds and the greens on preferably on the bottom of the turnouts, and that will change how the handle on your controller throws the switches. Now my controllers are all relational to the physical throw from the control board to the track. Thanks for watching. Hope it helped you out.